Welcome Tarun and Yash. Maybe wait for a few more minutes so that more people can join. Only two of you are here. Okay. Tarun and Yash, you can hear me, right? Just checking. Can one of you confirm that you can hear me?
Yes.
Right. Okay. As always, these live sessions are for uh, getting your doubts cleared. First of all, these are supposed to be the only interactive element of the course. So first, I'll ask, do you have any doubts in the about the videos, about the course, anything? Maybe take a minute. If you have any doubt, you can just unmute and ask me, or you can just put in the chat. I'll first get to your doubts, and then we can talk about some, as always, some general math questions if you are also up for it. Let me also check meanwhile if there are any new doubts in the forms. Okay, so in the Google Forms, there are no new doubts. There's just one, how to submit assignments. I hope they know that by now. There's a new student. Hello, um, Pavanamala Raju, I think. Yeah. Any feedback even? That's also okay. If you have any feedback or anything. Okay then. Okay, so maybe let's talk about two or three like general math questions, and even in the middle, if you get some doubt that you have to ask, you can just ask me. Okay, you can stop me in the middle anytime you want. Okay, I'll put a question in the chat. You just do it and tell me the number. The answer is just one number. Okay. So the question is, I put in the chat. The question is, three children have five identical chocolates to share. Okay, among them, a child can get any number of chocolates from zero up to five. In how many different ways can the chocolates be shared? Let me explain the question maybe. Like there are three children, so you can actually tell them apart. Child one, child two, child three, right? So what do I mean by how many different ways can the chocolates be shared? That means all the five chocolates can go to the child one, all the five chocolates can go to the child three, one chocolate can go to child two, and four chocolates can go to child three. These are all different ways, right? So what are the total number of different ways that the chocolates can be shared? If you have any doubt in the question, you can just ask me. We won't do a lot of questions because I don't want to keep you here for a lot of time. Yeah, we'll do maybe one or two and then we'll disperse. Okay, take a minute. This is yeah, this is doable. Maybe it will take a minute. Tell me the answer. Right. So I have right answers from two of you. So yeah, all three of you know. Yeah, the answer is 21. Perfect. So it seems some of you already know the stars and bars formula. That's good. That's good. You can do by brute force as well. But stars and bars formula is exactly what I'm going to talk about next. Okay, it's a formula. It gives you the answer. Sure. How do you derive the formula? How is the formula right? That is what we'll talk about now. Yeah, formulas give you the answer, but we want to see why the formula works. Okay, that is what will lead you to more formulas, more understanding, more questions, more answers, right? So why does a formula work? Yash, do you know like why that is the answer? 5 + 3
Uh,
- 1. Huh.
I think it's like you could like represent the like identical objects as like stars, and like you can divide them into like different bar. Like you can create there's like separating like there's k-1 bars which are
Mm-hmm.
needed.
Mm-hmm.
For example,
Mm-hmm.
like if you have three items, wait,
Mm-hmm. 5 items here. Yeah.
yeah, if you have five items and
Mm-hmm.
you want to put them in, you can the three bars, so no, there's three bins, so you can separate them into two bars.
You can separate them using two bars is what you mean, I think.
So yeah, 2 bars. Yeah,
Mm-hmm. Mm-hmm. So why you
that's
only
why.
need, yeah, so why is two enough? Why not three? Because we have three people. Why is three not needed?
Because if you
You're
like
right.
if
You
you
are
draw
right.
it out like
Okay.
visually, then
Mm-hmm.
like the three stars, and between them two, you can like draw two lines and like to separate them.
Mm-hmm. Right. I mean, you just need we just need two bars to separate the objects into three sections.
Yeah,
Is
yeah,
what you mean,
yeah.
right? Nice, nice, nice. Excellent, excellent, Ash. So uh, let me just explain what Yash just told. It is perfect. It is perfect. Okay, so the answer is number of items plus number of people minus one, choose number of people minus one. So here it will be 5 plus 3 minus 1, choose 3 minus 1. That will be the answer. Okay, why is that the answer? So you imagine you put all the objects first of all on a line. Okay, here you have 5 objects. The objects you put on a line. Okay, you take 2 bars. Okay, the idea is to separate these 5 objects into 3 sections so that we can just say, okay, the first section goes to the first person, second section goes to the second person, third section goes to the third person, right? Now the thing is, all you need is just 2 bars to separate these items into 3 sections, right? Okay, you'll put 1 bar, you will have 2 sections. Next, you will put the second bar, and you will have 3 sections, right? That's why just taking the number of people minus 1 bars is enough. Okay. Maybe I'll also like later in the meeting I'll also put some resource. You can get this in Wikipedia as well. It's a nice explanation. But the idea is just this: you want to separate k objects for n people. We just need n minus 1 bars to separate these k objects into n sections. Okay, and that gives us the answer. Right. So, a related question. Let me post in the chat. Maybe this will be too easy for you all. You have 3 children, 9 identical chocolates, but this time each child must get an odd number of chocolates. How many different ways can this be done? Very similar, but just there is just one more condition. And Pavanamalaju and Tarun, please stop me anywhere if I. Mhm. Right. Okay. This is easy for you all, I think. I see. I see. It is 10. I think you all know how to go about this, right? You just write. You just take two out, divide, and that. Yeah, yeah, yeah. Nice. All of you have gotten the answer. Let me put another one. 3 children, 9 identical chocolates, but this time each child must get at least one chocolate. Now, how many different ways? Yeah, are you sure, Pavana Malaraju? 36? I just checked as well. Yeah, it's not 36. Hmm. Yeah, maybe I'll put the solution for this in a minute. Right, right. Okay, I posted the solution as well. It's not much actually. It's a simple question. Right. Okay, I didn't know this would be too easy for you all. Hmm. Nice. Nice to know. Right. Hmm. So how many of you know about something called the Riemann rearrangement? Okay, I assume it will be new for all of you. Nice. So it goes like this. So let's say you add a finite number of numbers. Okay, 1, 2, 3, 4, 5. Okay, you add them in any order you want. 4, 5, 4 plus 4, 5 plus 4 plus 3 plus 2 plus 1, or 1 plus 2 plus 4 plus 3 plus 5. You get the same answer, right? No matter how, in what order you add a finite number of numbers, you'll get the same answer. 3 plus 2 plus 5 or 2 plus 3 plus 5 will give you the same answer, right? Let's say you add an infinite number of numbers. Would you still get the same answer in regardless of the order that you added them in? Is the question. Let's say you add an infinite number of numbers. For example, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 and so on. Okay, just to give an example of an infinite sum. If you added an infinite number of numbers, regardless of the order that you added them in, would you still get the same answer? Is the question. What do you think and why? Should I reiterate?
So could you repeat?
Yeah. So if you added a finite number of numbers, okay, let's say you added three numbers, okay, any three numbers, or let's say you added like five numbers, okay, five natural numbers, okay, no, any numbers, negative also doesn't matter, okay, you take three numbers, you add them in any order you want, you get the same answer always, right?
Yeah.
1 plus 2, always. So if you added a finite number of numbers in whatever order, you get the same answer. Now, let's say you added an infinite number of numbers. The question is, does the order matter now? That is, regardless of the order that you added the numbers in, would you still get the same answer?
No.
Why is that?
Like if you take like an infinite GP,
Uh-huh.
uh, then it converges to a value, right?
Mm-hmm.
But if you change the order of elements in a GP, then
Mm-hmm.
it does not converge to the value. Like you do not get the same.
But will it converge to a different value?
Maybe it
Also,
could
like,
diverge.
how do we know that?
I
Like
don't know.
how? So what makes you think it might diverge? We're just thinking out loud. Okay, feel free to just say what you think.
I guess if you,
Okay, so
yeah.
give me an example of a GP, and let's talk about a particular example, maybe. Okay.
Okay, so 9 and then you divide it by 3 continuously.
Mm-hmm.
No, wait, wait, no, no, wait, wait, sorry. The ratio has to be between -1 and 1. Wait, no, no, sorry, yeah. So
No problem.
9,
Yeah.
1 by 3, 1 by 9, 1 by 27, and so on.
So your first number is what? Sorry.
9. So
Okay,
9,
9.
3, 1, 1 by 3, 1 by
Mm-hmm.
9, 1 by 27, and
Mm-hmm.
so on.
Okay. So
Is that an infinite?
okay, it isn't. I mean, okay, it's
Yeah,
infinite sum. Now the question is, what will actually make this diverge? Like, what kind of order will make this diverge? Good choice, by the way. Good choice. Okay, so uh, Yash, your choice, right? Your choice of the sum
yeah,
actually will never diverge, no matter how you
yeah.
share the order. Okay.
Okay, yeah.
Uh, we'll talk about why. But can we think about some? Here's a spoiler. Order matters when you sum an infinite number of numbers. Can we think of an infinite number of numbers such that the order actually matters? What should that uh, infinite sequence of numbers have? What condition should they have so that the order matters?
What if you include both positive and negative numbers?
Yeah, excellent, excellent, Yash. Nice, nice. What standard are you in?
I'm 11.
Excellent, actually. If you took so if all the numbers in your sequence in your infinite sum are positive, and let's say it converges, okay, then it will always converge to that point. Okay, that is true, that we know.
Yeah.
Okay, that we know means, I mean, we have proof of that. We have to include negative numbers if we wanted the order to matter. Excellent. Right, so now can we think of an infinite sum where we have both positive and negative terms, and then we can think about its convergence and all that. Okay, this might be a bit too how to say, like, bit too out of scope. So okay, I'll give an example. Okay, so I'm just typing in the chat. Okay, so you have an infinite sum there, no? 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on. That is called the harmonic series. Okay, the names don't really matter, I mean, for now. If you wanted to look up later, you can just look up about harmonic series. That is the harmonic series. Okay, all the terms are positive. Actually, this series diverges. That is, if you add them up, even that is surprising. If you add these numbers, it goes to infinity. Okay, even that is surprising. But here's the thing.
Isn't this
If you
simplifiable?
simplifiable means
Like you can use partial fractions and simplify this. Like
simplify to do what?
it'll cancel out like uh wait, no. And
It's all positive.
sorry, yeah, never mind. Yeah.
Okay, yeah. So what if you just made a slight modification here? You alternate the signs in the harmonic series. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, plus 1 by 5, and so on. That is the alternating harmonic series. What is 113 by 60, Pavanamala Raju? Right. So now this for the start has what Yash wants. It has both negative numbers and both positive numbers, right? Uh, so yeah, she can also see that it should have infinite number of negative numbers and infinite number of positive numbers, right?
Yeah.
It had just a finite number of negative numbers. Then after a point, we just have everything positive, and up to that point, we can just add whatever number we get. We'll still have all positive series, right?
Yeah.
So we need to have infinite number of negative numbers, infinite number of positive numbers. That the series has. This alternating harmonic series has. Okay, series just means infinite sum. Okay, right. Now this is the thing. This German mathematician legend comes, Riemann, Bernhard Riemann comes, and he says, let's say you take a series, you make all the numbers positive. Okay, let's say you take a series. Let me type in the chart as well. Say you took a series and it converges. So this is number one. You you take a series and it converges. Converges just means you add them up, you get a finite value. Okay. Second, make all the terms positive. Now the series diverges. Okay, that is the second component. You make all the terms in your series positive. Now the series should diverge. Okay, this is the situation with alternating harmonic series, for example. So in that order, right, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, that goes to ln 2, I think. No, 2 times ln 2. No, just ln 2. Yeah, natural log of 2. Okay, but if you made all the terms positive, that gives you the harmonic series, and the harmonic series diverges. You with me, right? All of you with me?
Yeah.
Yeah. In this situation, what Riemann says is you can reorder. Now, hear me out. Like you can reorder the terms in your infinite sum to get any number as the answer, any real number as the answer. You get me? You can reorder the answer just doesn't change. It changes as much as it possibly could. You can reorder the terms in your sum so that you can get any real number as the answer. That is, for example, so this series, right, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. In this order, it gives you natural log of 2. There is an order. You just change the order and it will give you 1 crore. Change the order, it will give you minus 1 crore. Change the order, it will give you 10. Change the order, it will give you 1.00001. Change the order, it will give you 0.1112. Whatever real number. Change the order, you'll get 0. Whatever real number you can think of, there is an order for that. Now, here is the climax. That's an order for which the answer will be infinity. Just in one order, you get 0 as the answer. Change the order, you get infinity as the answer. Now, again, you change the order, you'll get minus infinity as the answer. and Riemann proved it, and it is called the Riemann rearrangement theorem. The first time I saw this, I was like gobsmacked. I was stunned. You know, the order changes everything when it comes to infinite sum. Okay, so should I reiterate anything? Have any questions? You can just maybe later, if you want, look at Riemann rearrangement theorem. If you want to dive deeper about this, is that okay? Yash, Tarun, Pavana Malaraju, and Shakti, yes.
Yes, sir.
Mm-hmm. Mm-hmm. And you can actually, I'm not sure if you can uh, explicitly find the order for each number, but for a lot of numbers, you have the order. Like uh, people know the order for which it gives zero, for which it gives one, and so on. Okay, I can just look up about that. Yeah, just wanted to uh, tell a bit about this small fun tidbit. Right, it's 5:40 now. If you have any questions, we can talk about it. And if we have no questions, you can give me feedback as well. If you have no feedback or doubts or anything, in a few minutes we can call it a day. I wish, I hope this wasn't too complicated. This rearrangement thing, I found it very interesting. I thought, yeah, anybody who is interested in math will find it very interesting. Yeah, how was this? Was it too complicated? Should I simplify things? Why the silence?
It was good.
Right, right. Thank you. Thank you all for being here. Thank you for being interactive. Thank you for answering. Right. Thank you. So I'll end this meeting then.
Thank you, sir.
Thank you. Thank you.